A molecular view of elements and compounds. Off the top of my head, I don't really know where this section is going, so this will be interesting. This is an interesting chart here. It kind of summarizes what we've talked about. Pure substances. There are two types of pure substances. There are elements and there are compounds. Elements only contain one kind of atom. But there are two different types of elements. There are atomic elements and there are molecular elements. Atomic elements, the individual atoms act independently, and in molecular elements, those act as a unit. So, for example, oxygen has little molecules that contain 2 oxygen atoms. There are some other ones, like sulfur has some molecules that have 8 sulfur atoms that are bonded together, and they act as a unit. Under compounds, we have 2 different broad categories of compounds: molecular compounds and ionic compounds. Molecular compounds are composed of discrete molecules where you have a specific number of atoms bonded to each other in a specific ratio. The example given here is water. We've got 2 hydrogen atoms bonded to 1 oxygen atom. All the individual particles are the same, but they contain more than one element, so it's a compound. That's molecular. The ionic contains ions, not molecules. And in the ionic compound, we've got a sodium atom and a sodium ion and a chloride ion. And they are going to be attracted to each other because of their opposite charges. But they're not going to form a discrete molecule. They form this large grid of alternating positive and negative charges. It's a little bit like building with magnetics. You guys at least seen those in a store. My kids have a big collection of magnetics. They periodically get them out, and then the cats play with all the metal marbles, and they all end up under the refrigerator. But you can make these things, and you can just go on and on and on until you run out of pieces, and they just stick together. And in chemistry land, that's what ionic compounds are like, playing with magnetic things, and they just go click, 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 and you stick them together. Molecules are not like that. Individual molecules are not going to just stick to each other like that. These I envision more as being marbles that are superglued to each other. Those are stuck. You can get them apart, but it's not easy. They are stuck to each other. And then these individual particles are going to do stuff. So atoms may be atomic or molecular. Atomic elements exist in nature with atoms as their basic units. So these names are descriptive. Atomic elements have individual atoms. Molecular elements exist as molecules. The ones we're going to learn about are the diatomic, meaning 2. Diatomic, 2 atoms. There are others, but we won't make you learn those. So more examples here. So here we see in mercury, which mercury is just a really fun element. It's sad that it's so toxic. But mercury is a metal, and it's a liquid at room temperature. And so it's really, really neat stuff. It's very shiny and dense, but it's also toxic, so we don't get to play with it. But what's inside this droplet of mercury? It's individual mercury atoms. Over here is an example of chlorine gas. Chlorine is also an element. But the individual pieces here are chlorine molecules. I think of chlorine as being like a junior high girl. I don't know if you noticed this in junior high. It was pointed out to me when I was a junior high girl, and even having had it pointed out to me, I still couldn't help myself. Junior high girls at school never go to the bathroom by themselves. Did you notice that? They always take a friend. I did it myself, and I recognized it as I was doing it, and I couldn't help it. I don't know why, but you don't go to the bathroom by yourself. You take a friend in there with you, right? So chlorine is like junior high girls. They go everywhere in pairs. You're not going to see chlorine atoms running around by themselves. They're always with a friend. Molecular element. There are 7 of these junior high type girl elements, and they all happen to be nonmetals, which in chemistry land, the nonmetals are girls, right? So here they are: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So when we find these as elements, their formulas are the element symbol with a 2, because they form diatomic molecules. Always. Now, sometimes hydrogen will go out with chlorine, okay, and form a compound, and then hydrogen is okay with not having another hydrogen with it, but you'll not find hydrogen by itself. It'll be in a compound or with another hydrogen atom in this diatomic molecule. So here's on the periodic table showing where these guys are. So you need to know these 7. And so there's 2 ways you can remember that. One is this mnemonic up here. Horses need oats for clear brown eyes. So these horses, H for hydrogen, N for nitrogen, O for oxygen, F for fluorine, Cl for chlorine, Br for bromine. It breaks down a little bit here. Eyes. Okay, yeah, that doesn't start with an I, but it sounds like I, right? So this is a homonym. So those are the 7. Another way is to look at the periodic table. If you can remember there's 7, find element number 7. Element number 7 is nitrogen. And then they form the pattern of a 7 on the periodic table. Isn't that cool? 7 starting with 7. Plus hydrogen, because he's the baby brother and he breaks all the rules. You like that? I think that's fun. So it's a 7. So you need to know those guys. Compounds can also be divided into 2 groups. I already talked about these a little bit. Molecular compounds are going to have 2 or more nonmetals. The ionic compounds are going to usually contain a metal. So molecular compounds are 2 or more nonmetals, and the ionic compounds are going to contain ions, and usually it's going to involve a metal, most of the time. Because the metals form positive ions, and the nonmetals form negative ions, and then they are attracted to each other. If you have 2 nonmetals being together, they're not going to be ionic because they would both be negatively charged and they would repel each other. So they form compounds in a different way.
So molecular compounds are always going to form negative ions?
Molecular compounds are not going to involve ions.
Not going to involve?
They're involving atoms,
Okay.
and they're going to be nonmetals. The molecular compounds will be nonmetals. So here's a couple examples. Here's a picture of dry ice, which is solid carbon dioxide. And in carbon dioxide, you have carbon dioxide molecules. It's really not all that clear in this picture, actually, but you've got 1 carbon and 2 oxygens. Carbon and oxygen are both nonmetals, and they're going to form a molecular compound. Over here, we've got sodium chloride, table salt, and if we look in here, we see that we have ions. We have chloride and sodium ions, and when we write the formula for this, we're going to give the lowest ratio. Because if you were going to tell how many are in a piece, it would be different for every piece, and it would be a huge number and pretty meaningless. So for the ionic compounds, we're looking at the ratio of ions, and so we call that a formula unit because it's not really a molecule. A molecule is a discrete unit that stays together. Ionic compounds are just like one giant array of positive and negative ions stuck together. And so we're going to look at the formula unit, the smallest ratio of the 2 ions. So when we have a metal and a nonmetal, that compound is going to be ionic. It's going to have ions. And the basic unit is the formula unit, not a molecule. So I kind of already said this. So they don't have individual molecules. but it's just this three-dimensional array. And since each piece is going to be a different size, there is no point in talking about the actual number of sodium ions and chloride ions in a particular piece of salt. So we're just looking at the ratio of sodium to chloride. So we need to be able to look at these things and classify them. So classify each substance as an atomic element, a molecular element, a molecular compound, or an ionic compound. So chlorine. It's an element, and it's one of the 7. It's the clear in clear brown eyes, so this is a molecular element. How about NO? First of all, element or compound? Compound, because it's got 2 capital letters. Molecular or ionic? It's molecular. Because we find nitrogen and oxygen on the periodic table, and they are both nonmetals. Nonmetals make molecular compounds, so we'll call this one MC. Molecular compound. How about AU? That's gold. That's an element. Is it molecular or atomic? Atomic. It's not one of the 7. Did any of you guys ever watch, oh no, I'm blanking on the name of it. Oh, there was this TV show that was on when I was a kid, which you may have seen on reruns. There's a bunch of girls at a boarding school, and there was Blair and Tootie. Yeah.
Facts of life.
Facts of life. Thank you. Facts of life. So Tootie had a great way of remembering the symbol for gold. She's like, that's what you say when someone steals your gold. Hey, you, come back here with that. Na2O. Element or compound? Compound. Ionic. Why? It's got a metal in it. Ionic compound. Ick. How about CrCl3? That's going to be a compound, right? Got to find Cr on the periodic table. It's a metal. So that's going to be ionic. So, let's take a little trip to chemistry land. The metals are the men, the guys, and the nonmetals are the girls. Okay? And so when we have a guy and a girl, there's this attraction. Okay? And so that's when we get the ionic compound. And when we have the 2 girls together, it's more of just a friendship thing. Yeah. Okay, that's going on YouTube. Great. Oh, it's at the end. Maybe I could cut that off.